Good morning, this is Dr. Turner for Integrated Math 2. Today we're going to be covering 4.1, which is solving quadratic functions in the form x squared plus bx plus c. You may notice that there was not a 3.5. This assignment is going to be on your Unit 3 test because Unit 4 is a little bit longer. So I apologize for the confusion there, but it's a pretty straightforward lesson. So it should be pretty quick here. So we want to now be able to solve quadratic equations. Well, what does that mean? When we solved linear equations, the goal was always to get x by itself, right? Both quadratic equations, because we have a second degree, it means that potentially there are going to be two answers. Unit 4 is going to be all about different ways that we can solve quadratic equations, but we're going to start with factoring. In Unit 3, if I gave you something like x squared plus 8x plus 12, and if this was a function, if I wanted you to put it in intercept form, you would factor. And we talked about a number of ways of factoring. The numbers that multiply to get 12 that add up to 8 using the magic x would give me 6 and 2. So you could rewrite it as x plus 6 times x plus 2. That's basically all we're doing in this section. But now what we're going to do is, rather than having just a plain function, we're going to have an equation. And so what I'm going to do is I'm going to set this equal to 0. Okay? So that's going to be the only difference between this and when we were just doing intercept form in Unit 3. Solving this, we need to know what numbers would make this 0, right? So what could I plug in here so that I get 0 equals 0, which would mean I would have a true statement? Because this is multiplication here between the two factors, if I can make this 0 or if I can make this 0, then the whole thing's 0. So what we're going to do, say, split this into two equations because we have two answers. X plus 6 equals 0, and x plus 2 equals 0. Solve for x by subtracting 6 on both sides here, subtracting 2 on both sides here, and I get x equals negative 6, and x equals negative 2. So that's the only difference. Now, when you start doing this a few times, you can probably look up here and see, okay, well, what could I plug in there to get 0? It's the opposite, right? So negative 6. And likewise, x plus 2, the opposite, it's a negative 2. So once you're comfortable with that, you can just tell me x equals negative 6, x equals negative 2. But for now, while you're learning it, might help to write this step to remember. Okay? So I'm going to go through a few examples here. X squared minus 10x plus 21. So if I'm using the x, I'm looking for equals 0, sorry. So if I'm using the x, I'm looking for the numbers that multiply to get 21, but add up to negative 10. Use your techniques there. You get negative 7 and negative 3. So factored, this is x minus 7 times x minus 3. Therefore, the answers would be positive 7 and positive 3. X squared minus 12x plus 40 equals 0. Looking for the numbers that multiply to get 40, add up to negative 12. Oh, sorry, let's change this so it's factorable. Let's change that to a minus 14. Therefore, this is going to be negative 10 and negative 4. Write it in factored form or intercept form, x minus 10 times x minus 4 equals 0. Therefore, the answers are 10 and 4. So in these examples, I ended up with 2 solutions. Typically, that's going to be the case. However, there are some cases where I have only 1 solution or I don't have any solutions. We'll talk about the no solutions in later sections. All of these will have a solution, at least one. The equations that only have 1 solution also we'll be talking about here in a few later lessons. The quadratics that we end up with just a single solution are when we have what's known as a perfect square trinomial. So for instance, x squared plus 10x plus 25 equals 0. When I factor that, looking for the numbers that multiply to get 25 that add up to 10, I end up with the same number. So this is x plus 5 times x plus 5, or I could just write that as x plus 5 quantity squared. Therefore, x equals -5, right? There's no need to write the same answer twice. Another example here, x squared minus 81, for instance. And this one we could use a couple different techniques, but since we're factoring, look for the numbers that multiply to get -81, but add up to 0 because there's no b term here. That would be 9 and -9. So x plus 9 times x minus 9 equals 0. Therefore, my answers are -9 and +9. We'll be doing more examples in class. If you guys have questions, please reach out to me. Otherwise, have a good day, and I will talk to you soon.